Let's start with the first example. We want to describe the intervals of continuity for each function. Like I mentioned on the previous video, we care about the domain. Yes, this continuity will happen also on the y values, but we're going to describe them using the domain or the x value where we have our discontinuity or continuity. If you look at the first problem and the first graph, do I have any similar piece of my graph that looks like a jump discontinuity, an infinite discontinuity, or a removable discontinuity? It looks like I don't. It looks like my graph keeps on going smooth and I can draw it from the left to the right without lifting my pencil from the paper, which means my domain or my range for which this function is continuous is all real numbers. Now, for our problem B, if we look at it, we do have a hole. We do have a value on our x that it's undefined on my function. Again, this is a removable discontinuity or a hole. And it looks like my function is continuous everywhere else but 3. My x cannot be 3. And if I use my interval notation form, from negative infinity all the way to that almost 3, it looks like I can graph my function without lifting the pencil from the paper. And then right after 3 is going to keep on going smooth. So my interval is going to be from negative infinity, because I'm coming from a negative side of my x-axis, all the way to almost 3, not touching the 3. It does not include the 3, so I need the open interval. And then right after 3, not touching the 3, all the way to positive infinity. To join these, remember we use the symbol union, and those two will be my answers for this particular problem. Our real numbers, and from negative infinity to positive infinity, excluding the 3.